Have you ever wondered why every living thing on Earth, from the tiniest microbe to the giant blue whale, is made of carbon? Why not another element, like silicon, which sits right below carbon on the periodic table and shares some similar properties? It's a fascinating question, and the answers reveal just how special and perhaps inevitable carbon-based life really is. Today, we're diving deep into the cosmos and chemistry to uncover 3 startling reasons why life chose carbon. Let's start with the basics. What does it mean to be carbon-based? It means that the fundamental building blocks of life, proteins, DNA, fats, and carbohydrates, all have a backbone made of carbon atoms. Carbon is the ultimate team player in the molecular world. A single carbon atom can form 4 strong bonds with other atoms, including other carbon atoms. This allows it to create long, stable chains and complex ring structures. Think of it like a versatile Lego brick that can connect in 4 different directions, allowing for an almost infinite variety of shapes and structures. This structural diversity is the key to life's complexity. From the intricate folding of a protein to the double helix of DNA, carbon's ability to build complex, stable molecules is unmatched. So, what about silicon? On the surface, it seems like a great alternative. It's also in group 14 of the periodic table, meaning it too can form 4 bonds. And it's incredibly abundant on Earth. In fact, it's the second most abundant element in the Earth's crust, right after oxygen. You find it everywhere in sand and rocks, in the form of silicon dioxide. If life just needed a common element that could form 4 bonds, silicon looks like a prime candidate. So why isn't our world filled with silicon-based creatures, crystalline trees, and rocky animals? The first major reason comes down to the strength of its bonds. While silicon can form 4 bonds, its bonds with itself silicon-silicon bonds are significantly weaker than carbon-carbon bonds. Imagine building a skyscraper with weak materials. It wouldn't be very tall or stable, would it? The same principle applies at the molecular level. Life requires large, complex molecules that can withstand the rigors of a dynamic environment. The strong carbon-carbon bonds create a stable and reliable framework for these molecules. Silicon chains, known as silanes, are much more fragile. They break apart easily, especially in the presence of water, which, as you know, is pretty essential for life as we know it. A life form built on a wobbly, unstable foundation just wouldn't last very long. Carbon provides the robust, reliable scaffolding necessary for life's complex machinery to function without constantly falling apart. But the story gets even more interesting when we look at how these elements interact with other common elements, especially oxygen. This brings us to our second startling reason, the problem of waste. Every living organism needs to metabolize, it needs to take in energy, use it, and get rid of the waste products. For us carbon-based life forms, this process is incredibly efficient. We breathe in oxygen. Our bodies use it to break down carbon-based molecules like sugars to release energy, and we exhale the waste product, carbon dioxide or CO2. Now, think about the properties of CO2. It's a gas at the temperatures we experience on Earth. This is hugely important. As a gas, it's easy to expel from our bodies. We just breathe it out. It dissolves well in water, like our blood, making it easy to transport to our lungs. And it can then be used by plants for photosynthesis, completing a beautiful planet-wide cycle. It's an elegant and efficient system for waste disposal. What happens if you try to do the same with silicon? When silicon reacts with oxygen, it doesn't form a handy gas. It forms silicon dioxide or CO2. Does that sound familiar? It should. Silicon dioxide is the primary component of sand and quartz. It's a solid, a rock. Imagine if every time you metabolized, you produced tiny grains of sand as a waste product. How would you get rid of it? You couldn't just exhale it. Your body would slowly fill up with solid waste. It's a logistical nightmare for any potential life form. This waste disposal problem is a massive roadblock for silicon-based life. The simple physical state of its oxide makes carbon vastly superior for building a dynamic metabolic system. Life needs to flow, and you can't flow if you're clogged with sand. Now for our third and perhaps most mind-bending reason, which takes us from chemistry to the stars. The abundance of elements in the universe isn't random. It's a direct result of the life cycle of stars. After the Big Bang, the universe was mostly hydrogen and helium. Heavier elements, like carbon and silicon, are forged in the fiery hearts of stars through nuclear fusion. But they aren't created in equal amounts. Stars like our sun spend most of their lives fusing hydrogen into helium. As they get older and hotter, they start fusing helium into heavier elements. A crucial step in this process is the triple alpha process, where 3 helium nuclei fuse to create a carbon nucleus. This process is incredibly fine-tuned. Physicists have found that if the fundamental forces of nature were even slightly different, this reaction wouldn't happen efficiently, and the universe would have very little carbon. It's a cosmic coincidence that allows for the abundant production of carbon in stars. Silicon is also made in stars, but in much larger, hotter, more massive stars, and later in their life cycle. These massive stars live fast and die young, exploding as supernova and scattering their newly forged elements across the galaxy. While this process creates silicon, it also creates a lot of other elements. The net result is that, on a cosmic scale, carbon is significantly more abundant than silicon. For every 5 carbon atoms created in the universe, there is roughly only 1 silicon atom. So, from the very beginning, the universe was seeded with more of the raw material for carbon-based life. When you're trying to build something as complex as life, you start with the most common and suitable building blocks available. Carbon was not only the better chemical choice, but it was also the more readily available one across the cosmos. Life, it seems, simply took the path of least resistance, using the element that was both superior for the job and more plentiful. So, to recap, carbon's ability to form strong, stable bonds allows it to build the complex, durable molecules life needs. Its waste product, carbon dioxide, is a gas, making metabolic processes clean and efficient. And finally, thanks to the physics of stars, carbon is simply more common throughout the universe. Does this mean silicon-based life is completely impossible? Not necessarily. Science fiction loves to imagine crystalline creatures on distant, alien worlds. Perhaps under very different conditions like a super cold planet with a methane or ammonia ocean instead of water, silicon's properties might become more favorable. But here on Earth, and likely in many other parts of the universe that resemble our own environment, carbon is the undisputed king. The story of why we are carbon-based is a story about chemistry, physics, and astronomy all coming together. It shows us that life as we know it isn't an accident, but a logical outcome of the fundamental laws and materials of our universe. It's a beautiful reminder that we are, quite literally, made of stardust, and very specific, very special stardust at that. What do you think? Could silicon life exist somewhere out there in the vastness of space? Let me know your thoughts in the comments below. I love reading your ideas. Thanks for watching, and if you enjoyed this journey into cosmic chemistry, don't forget to like, subscribe, and hit that notification bell for more explorations of our amazing universe. See you next time.